I have it here. Did you get an answer for 1A?
Yes.
Right, Grace, what did you get for 1A?
800.
Huh? 800? Yeah, that's what you're saying, 800, is it? Yeah. What did you get?
800.
You got 800?
800 joules.
Yeah, the unit is joules, yeah. So, work is force by distance, which is 200 by 4. So it's 800 joules. Okay. Now, what's the pressure? What's the formula for pressure? Force over area. What's the force?
Force
200. And the area is 0.15 multiply 0.05. Grace, what did you get? I'm picking on Grace today. Good, I'm glad. But what did you get? 26,667, we'll say. Yeah. No, sorry. What's the unit? No, pressure? Pascals. Yeah. Okay, that's okay then, yeah? Yeah. No, the B part, sorry. Well, actually, everybody got this, so I'll go to the next one. 2A. So you have 20 kilograms and it's lifted 1.5 meters. So what's the force here?
The force is 20 multiplied 9.8.
Yeah, but why is that?
Because the weight and the acceleration is down. The G is down. So weight multiplies G.
Almost, not quite. The reason is, if this man wants to lift it with a force F, how much must his force be? It must be 20G.
The same.
Yeah, so he can lift it. So the force must equal 20G, and look, there's the distance. So the work equals 20G multiply 1.5. Huh?
96.
What did you guys the answer? 30G? 30? No, bigger than that. 294, yeah, 0.3 joules. Amanda, are you okay?
Yes.
Do you need to go get a drink or something? Are you sure? If you need to get anything, you just let me know, okay? Alright, can I go on?
Yeah.
Yes? So, in the B part, his hands are like little circles. Yeah? He's got little circle hands. So, the pressure is the force over the area, which is 294 over. Now,
Pi r squared.
pi, and what's the or? 0.04 squared.
Yeah.
Yeah? True? No. Forgot something.
What?
He has two hands. So we have to put the 2 here. He has 2 circle hands. Yeah? Alright. So I got 29275 pascals. Did anybody remember the 2? No.
Nobody.
Nobody remembered he had 2 hands.
I supposed to think that I had 2 hands.
Yeah, how are you supposed to know this man had 2 hands? What a ridiculous idea. Okay, can we go on to number 3?
Yes.
Yep.
Something.
Yeah.
That's what that's force is different.
The force is 2... Oh, sorry, I put in the wrong number. So sorry. Guys, I put in the wrong number. It's not 294. What should I put here?
196.2.
Yeah, 20G. Okay, thank you. Thank you for help. 20 times 9.81 divided by 2 divided by pi divided by 0.04 squared. 19516 pascals. Yeah? It's my mistake. It's the force, which is 20G. I put this number in. That was wrong. That's the work. I need to use the force, which is 20G.
G, what do you call it? G?
Just G.
G.
Just G.
Acceleration. G.
G is acceleration too. Gravity
Yeah.
acceleration. Yeah. Yeah. I'll just say G. Can I go down? Yes. Okay. Grace, can I continue? Come on, did you write this down?
Yeah.
You can let her have a look then. Okay, 3. A boy starts to pull a car. The car is 10 kilograms. Over kg. I actually kind of like that as your name now. kg. kg.
Kilogram.
Yeah. kg. I like it. Yeah. Okay. So we have 10 kilograms, and there's a rope here, and I say it is 98.1 newtons. So we have a force here, and a force here, and this is 45 degrees. So this is 98.1 cos 45, and this is 98.1 sin 45. Okay, so how long does he move it for?
There's not enough information.
I didn't say. That's stupid of me.
Yes, there's not enough information.
Yeah, that's ridiculous. Let's say...
100.
No, the boy doesn't put it for 100 meters. What would we say?
20.
No, not even 20. 2. Right, sorry, this is missing from the question.
Yeah. I put a big question mark.
Good for you. I'm glad you're taking it seriously. Right, so how much work is being done? It will be 98.1 cos 45 multiplied by 2. Yeah, why did I use this one?
Because there are force horizontal.
Well, the force is not horizontal though. What is horizontal is the movement.
Movement is movement.
This is why. Yeah.
Teacher.
Yeah.
The force.
Whoa! One at a time. Clara was slightly ahead of you. Yes.
Okay, this is the mass. If the force was angle,
Yeah.
so the movement will be easier, or?
No. For this type of problem, the angle should be small to make it easier to do. Yeah.
So just horizontally.
It's the best.
The best.
Yeah. Yeah. 98.1. Oh, sorry. Yes, what were we saying? Force multiplied distance. So the boy did 139 joules of work. I better make a note here. What's wrong?
Yes, because in the question he asked this as 2 meters.
Is this about the 2? I forgot to write it here.
Yeah, it's your fault.
It is my fault. Oh no! I accept full responsibility. It's my fault, yes. Yes. And this is the problem.
I don't know if
Okay. Can I do number 4 now?
Yes.
Yeah, sure.
Yeah, did anybody get it?
Yeah.
Yeah.
Really? I'm
Yeah.
impressed. What answer did you get for the work?
Did best.
Yeah, okay. Amanda, you said you got an answer?
No.
No, okay. So no, did anyone get an answer?
No.
The what?
Yeah?
189 point?
Yeah, 199.7.
189.1152.
You got 199. What did you get?
I get 189.
We'll see. We'll see. Okay, so for the last one here, what you have is you have a plane that's taken off. That's my plane. Oh, I'll make it look a bit more like a plane. Here's my plane. Yes. And the plane takes off and it's moving this way. Yeah, it's a potato plane. Now, the plane is quite heavy. It's 80,000. Yeah. G.
Yeah?
That's what I say, 80,000 is the weight. G.
No wonder.
What did you use? 8?
But you that is kg.
Yeah. Yeah. 80,000 kg, and this is the weight. This G is G, gravity G.
Okay.
Relax. 9.81, is that better?
Yeah.
Okay, alright. Now, there's a force making the plane go up here. So this is 45 degrees. So this is F cos 45. And this is F sine 45. Okay, so far, is this okay? So far, yeah? Now, I also say in the question that the plane is accelerating up with 3 meters per second squared vertically.
Yeah.
Now, I think some people may have thought I meant 3 this way. I didn't. I said in the question, it's going up with 3 meters per second squared. Yeah. Yes, that's right. Just to be clear, look, guys, look. What's happening here with the plane is it's going like this. There's an acceleration. It's accelerating this way and it's accelerating this way. I don't tell you this one, I only tell you this part. Do you remember with the projectiles, we said it accelerates here with 9.81, and then what about this way? 0, yeah. I don't tell you this one. I only tell you the vertical one. Back here. It's accelerating vertically with 3.
Yeah.
You don't know what this one is.
Okay.
You don't know it, okay? And you definitely don't know this one. Also don't know. I only tell you the vertical. Okay, so if I go back. Now, how much force is there vertically? What are the vertical forces? What are they? The vertical forces. Yes, Amanda, you think you know? This one, isn't it?
Yeah.
And this one.
No.
Yeah.
No? Yeah.
They plug together.
Yeah, how do we put them together now? Is that the door there? KG? Yeah, so your question, Amanda, is do we add them together? Like, how do they combine? Which is bigger? This one or this one? Which is bigger? This or this?
This one.
Up or down?
Down. Down.
Up. Which way is the plane going?
Oh.
So this force must be bigger than this.
Why?
Because it's going up.
Because it's
How
wide.
does it cool down?
Because it's wide.
No, yes, it's not up equals down. Up equals down if it's not moving. But it is moving.
Oh.
Because the plane wants to go up, so
Yes.
the force put up,
Yes.
so they can go up.
Yes, 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 yes. So we have F equals F sine 45 minus 80,000 G. Is the total, correct. And that equals MA. And we know what the A is. What is the A vertically? It is 3. So, can we find the F? Definitely. Let's calculate it. So we calculate that the F equals 1449286 newtons. That's the F when you solve this. And what we did here was I used that the total F equals MA. What law is this? Newton's second law. Okay. Now we know what the F is, so we know what this is. Can I go back? Can I go down? Can I go down?
Write down the total force equal mass.
This is Newton's second law,
Yeah.
and this is what I used here. This minus this is the total force equals MA. Make sense? Yep. Okay.
Okay. I put the total force in the work.
Yes,
I put it.
because the plane is moving vertically, so we should use the total force. Yeah.
We should use the total.
But before I go on to that, what I'm going to... Well, yeah, I'll go on to that now. Can I scroll down?
Yeah.
Alright, so look, here's our plane. Potato plane. What did I say the force was? Can you read it back to me? Or maybe I can see it. No, I can't. 1449286 newtons. And what was the angle? 45 degrees. So if I do cos 45, I get 1024800, and then this way is the same, 1024800 newtons and newtons. Yes. And then, what is the weight? It was 80,000 G. So 80,000 G is 784,800 newtons. $784,800. Okay? Yeah. Now, what did I say the acceleration vertically was?
3.
3. Now I want to know what the acceleration horizontally is. So I can use F equals MA. So A equals F. Now what F do I use?
The horizontal.
This one, yeah? 10,24800 divided by 80,000. So, before I type in the answer, do you think it will be bigger or smaller than 3?
Smaller. Bigger.
Yeah, which?
What's this?
This here is an 8. It's the mass. Bigger or smaller? Give me an answer, what do you think? No.
Bigger.
Before you type it in. Bigger because?
I don't know, I guess.
Well, look, vertically you have a weight which reduces the force. Whereas horizontally, do you have any drag? No. So there's more force, so there'll be more acceleration. In fact, the answer is 12.81. Yeah, meter per second squared. So now finally, I can put these two together to get the acceleration this way. Square root, that squared plus 3 squared, and this will be 13.16 meters per second squared. The square root, I use this one and this one with, the square root. Pythagoras. Here. This one, Amanda. I get this answer here. I used Pythagoras. Because this way is 3, this way is 12.81, so I have to get this way. Yeah. Okay, can I go down?
Yeah.
Yes?
Yes.
Okay. So now we're at the last part of the question, getting to the answer. So, what was the force going this way? We got 144, 928, 6 newtons. And then, what was the acceleration? What was it? 13.6. Now, let's do our UVATS, so we can get the S. We'll say the plane starts at rest. The acceleration is 13.16. And what's the time? In the question, I say the time is 1 minute. So what's the time? 60 seconds. Right, so we can say S equals UT plus a half AT squared. So that will be that divided by that divided by times that. So the S is quite big, as you might expect. 23 kilometers, 23,682 meters. So look, now I have my S, and I have my force. So now I can finally get the work. The force was 144,9286. So the work will be a huge number. 34,322 megajoules, or if you want, that's 34.3 gigajoules. I think might be better. Which is not surprising because, lifting a plane up into the air is a lot of work. So it should be a big number. Now, look, this question was an exam question, but the good news is it was a section B question, which means they broke the question into parts for you to do. So like part 1 of the question they said was to calculate this and this, and then part 2 of the question was calculate this and this. And then part 3 was, they do it in steps for you.
Section B is also has steps.
In section B it's done in steps.
That's true.
Yeah, so this, I know it seems long and difficult, but if you got this in the exam, they would break it into steps for you. So, I'm sorry, it wasn't 199 or 189, but it's good that you tried. Yeah? Was question 1, 2, and 3 okay? Yeah. That's the most important thing. Okay. Right, we'll go on to the next topic now. Yeah. Yes.
A is a number or it's 9.81?
The A in this question? In any question? Yeah. Well, you have a choice. if you know f, you could use this formula, if you know the f and the n, because then a is f over m. If you don't know f and m, but you know u, v, t, and s, what?
Right down.
Okay, well I'll leave it here, don't worry. Then you could use v equals u plus at, then this means a equals v minus u over t. That's one way, that's another way. What other formula do we have? You have v squared equals u squared plus 2as. So you could get a is v squared minus u squared over 2s. That's one way. Any other ways? We have another formula, don't we?
Yeah, that's
Yeah. You have
UT plus
s equals ut plus a half at squared. So let's see, you could say, s minus ut over a half t squared. That's another one for a. So I've got 1, 2, 3, 4 ways to find a. Any other ways? No. I'll leave them there. Don't panic. I'll leave them there for a minute for you to write down. And Grace, remember also, I'm recording this. I'll put it on Moodle later.
Huh? What do you do?
What's Moodle? I am making a video now. You can watch this again later on Moodle. Got it? Moodle, not noodle. Yeah? Yes?
I think maybe it's not remembered because we have our four formulas.
Yeah, you need...
Because
Yeah.
she's lazy, she don't want to remember.
Don't say she's lazy. Is she lazy?
I think she's lazy, so she don't remember everything formula.
Did you hear what she said? That's terrible. You should be kind to her.
How should I come to her?
You should help her. No? Not interested?
Every day she does it, what's A, what's V, what's T.
Okay, if you don't help her, maybe you can help her, correct?
Okay.
Yeah?
Like
Yeah, if you can, yeah. Okay, what? What's wrong, KG?
K.
Sorry, KG just sounds much cooler than KJ now from our physics class. Yeah? Or you could also go for KM. KC? KC? So there's already somebody called KC. Yeah, the reason I did that actually is because I think there's another student called KC. So I got your name mixed up. Because there's already KC and now KJ. So, if you don't want to be KG, I can be KG. Yeah. Or KM. Right. Alright, did you write that down, Grace? Yeah. And Carl, can you give Grace that question earlier that, which was number 3 or something, that you didn't finish? No, in your notebook.
Yeah, sure.
You know which one? You said you need to write it down.
Yes.
Yes.
Already.
Oh, you got it? Yeah, okay, alright. Can we go on to the next topic?